Okay, I hope I am audible to all the students who are attending this lecture. We continue with preliminaries. We continue with preliminaries, which is unit 1. Okay, unit 1 of MME. Okay, so in the last lecture, we had started with the set theory concept and we had done the properties also. We had done set operations, union, intersection, difference, disjoint, and complement of a set, along with their Venn diagrams. So now all students will write the heading, some important properties of sets. Some important properties of sets. So first property, idempotent law. Idempotent law tells you what? If you take the union of a set with itself, it will give you the set itself. If you take the intersection of a set with itself, it will give you the set itself. So A union A is equal to A intersection A is also equal to A. Second property, commutative law. Commutative law states whether you take A union B or you take B union A, they will be the same. Whether you take A intersection B or you take B intersection A, they will be the same. Okay, so union operation is also commutative, intersection operation is also commutative. Third property, associative law. A intersection B, if you associate it with C, it will be the same as if you associate A with B intersection C. Similarly, if I take A union B and then take its union with C, it will be A ka union with B union C. This is my associative law. Fourth, distributive law. Distributive law. If I take A ka intersection with B union C, if I open up the brackets, the sign will change. That means A intersection B union A intersection C. And A ka union with B intersection C will be A union B intersection A union C. Okay, so we can even prove the distributive law using Venn diagram. So see, if I draw a Venn diagram, see I am drawing two Venn diagrams. This is A intersection B union C and this is A intersection B union A intersection C. So let me shade the areas A, B, C. A, B and C. So let's look at the areas. Okay, so what will A intersection B union C be? So my B union C is this whole area. This whole area is B union C. What is A ka intersection with B union C? A ka intersection with B union C is only this area. Similarly, look at A intersection B. On the right hand side, A intersection B is this. Ka union with A intersection C. A intersection C is this. So you can see these two areas are equal. Two areas are equal. Similarly, you can try at home the second one. Try A union B intersection C and A union B intersection A union C. You will observe that through Venn diagram, they will have the same area. Okay. So I hope all these four laws are clear to all the students. Idempotent law, commutative law, associative law, and the distributive law. So moving forward, some important notes, or I can say some important observations. Okay, so first observation is, if A is a subset of B, I am not saying proper, I am saying if A is a subset of B, then guys, what will A union B be? If A is a subset of B, A lies within B, so A union B will be B itself. Similarly, if A is a subset of B, what will their intersection be? A itself. So always remember, when we take the union, the bigger set wins. When we take the intersection, the smaller set wins. When we are talking about subsets. Okay. Second observation, since phi is a subset of A and A is a subset of the universal set, all of us know that phi is a subset of every set. We know that from class 11th mathematics. We know that phi is a subset of every set, and every set is a subset of the universal set. So if phi is a subset of A and A is a subset of the universal set, then A ka intersection with phi will be phi, A ka union with phi will be A ka intersection with the universal set is A ka union with the universal set is the universal set. Again, the concept here is, when you are taking the intersection, the smaller set wins. When you are taking the union, the bigger set wins. Okay, very important. A ka intersection with A complement, what will that be? A ka intersection with A complement will be phi. Why? Because since A and A complement are disjoint sets, they have nothing in common. A and A complement have no element in common. Their intersection is phi. And what will A union A complement be? it will be the whole universal set. Why? Because since A and A complement are exhaustive. Exhaustive means they cover up the whole set, universal set. They exhaust the whole universal set. So A ka intersection with A complement will be the null set, and A ka union with A complement will be the universal set. Then we have the De Morgan's law, which all students have done before. De Morgan's laws. First law is A intersection B ka complement will be A complement union B complement. Okay, you want to have a look at the Venn diagram? So I'm drawing two Venn diagrams. Universal set. Okay. In both the diagrams, I'm drawing the sets A and B. What will A intersection B ka complement be? A intersection B ka complement means A outside A intersection B, I shade all the area. Outside A intersection B, I shade all the area. What is this? This is A intersection B ka complement. And what will A complement union B complement be? Now A complement is all the area outside A. All the area outside A is A complement. And all the area outside B is B complement. All the area outside B is B complement. So if I take a union of them, what will that mean? Union of them will include the red color also, the blue color also. That means all the area except this area. You can see all the area except this area. So this is nothing but A complement ka union with B complement. You can see the two are exactly equal. The two are exactly equal, because on the left hand side also only this area is not shaded. On the right hand side also this area is not shaded. And the second De Morgan's law, A union B ka complement is A complement intersection B complement. So try to show this using a Venn diagram. Try to show this using a Venn diagram at home. So I have done one for you, one you will try at home. Try to show this using a Venn diagram. A union B ka complement will be A complement intersection B complement. Okay, now two more things left in set theory. Let's do a practice question. Let's do a practice question. Consider the following Venn diagram. Consider the following Venn diagram. And look at what I am labeling. This is 1, 2, 3, 4, 5, 6, and 7. So find what is 1 denoting, what does 2 denote, 3 denote, 4 denote, 5 denote, 6 denote, and 7 denote. So what does 1 denote? 1 denotes A and B but not C. A and B but not C means A and means intersection B but not C. That means minus C or slash C. So 1 denotes A ka intersection with B but not C. What will 2 denote? B intersection C but not A. What will 3 denote? 3 will denote A intersection C but not B. What will 4 denote? 4 denotes only A. How will I write only A here? A but not B union C. How will I write only A? Only A means only this part. Only this part. That means A but not B union C. How will I write 5? Only B, which is B but not A union C. How will I write 7? How will I write 6? Only C. And only C I can write as C but not A union B. And all of us know what is 7? A intersection B intersection C. So I hope all students have understood how to represent the areas when we have 3 sets, A, B and C. And now we are doing the last thing for the day, after which we stop. Okay. So let's write this: symmetric difference between sets. Symmetric difference between sets. Okay, so let A and B be 2 arbitrary sets. Then define the symmetric difference. Define the symmetric difference between the sets A and B as A symmetric difference B is A but not B ka union with B but not A. So I repeat, if A and B are 2 arbitrary sets, the symmetric difference between A and B is defined as A triangle B is equal to A but not B ka union with B but not A. Venn diagram: universal set A, B. What will A but not B be? This portion. B but not A, this portion. So the shaded area is A symmetric difference B. An important point to note: A ka symmetric difference with B is equal to B ka symmetric difference with A. But A but not B is not equal to B but not A. This is what? This is A but not B. This is B but not A. A but not B is not equal to B but not A. But the symmetric difference is equal. Whether you do A triangle B or you do B triangle A, you will get the same answer. So guys, with this, our theory on sets is over. And this is where I stop in the MME lecture today. I hope all students have enjoyed the lecture. Any doubt, you can unmute your mic and ask, or you can call, or you can mail me your doubts at divineschooloфeconomics@gmail.com. So now I request students to leave this meeting and join back using the same link. Leave this meeting and join back using the same link.